Okay, some more problems from section 5.1. This is number 13. And these are always kind of fun. The more outrageous they look, the more fun they are because, you know, it's like a puzzle. It's like making your way through a maze. It's kind of like a challenge, you know. So it's like I said, it's a lot of kind of fun working these things through here, seeing if you can make it work. And you look at this mess over here, and that's a sine of theta. All right, here we go. So let's see if we can simplify this. So again, probably our basic approach would be to put everything in terms of the sine and the cosine, and then go from there. So the tangent, and it looks like I'm going to have a complex fraction, so this is going to be more fun and games. So this would be the tangent of theta, which is the sine of theta over the cosine of theta times, oh, wow. That's sort of silly, isn't it? Well, you can see it this way. I guess it's easier to see. That's just going to, I could just think of this as 1 over the tangent, too. That would be easier. I'll just do it like this. It's sort of silly, but that's the cosine of theta over the sine of theta. And usually I usually don't see those, so because it's happened so easily. So, all right, and then this is going to be 1 over the sine of theta. So this is a little roundabout because look at this. This cancel. They cancel. That's 1. And you could have done it like this too. And I should have probably done this as the tangent of theta times 1 over the tangent of theta, because that's what the cotangent is. So either way, you're going to get, you know, this is like over 1. So the same thing. I wrote it like that just because I started writing. It's easier than just to start a new sheet of paper. But either way, you get 1. So now I've got 1 over the sine of theta. Does that equal the sine of theta? Okay, well, we could multiply by the LCD, or we could invert and multiply. You know, either way, we could do it the old way or the new way. If we multiply the top and the bottom by the LCD, that's what we're going to get. So if I multiply the top by the sine of theta, and the bottom by the sine of theta, up on the top I just have the sine of theta, and on the bottom these cancel, and I just have 1. And that is indeed equal to the sine of theta. So there's lots of, like I said, there's lots of ways to do these. So there's 2 ways right there you could do that. So, okay. So there you go. That was pretty easy. That's one way. Like I said, there's lots of ways. Now, if we gave you a problem like this, something like this, we might say simplify this to be one of the identities, and then you could work your way through it, or to be a single term identity, or trig function, I should say. All right, let's try number 15. And again, this is 5.1. And number 15. Okay, the sine squared of theta equals 1 plus the cotangent square root of theta. Oh, I'm sorry, that's times that, pardon me. Does that equal 1? Okay, so what's 1 plus the cotangent squared? Now, this is one of those trigonometric identities, but sometimes we confuse these. You know, you could look at it on your sheet and you can see it there. So I guess that's one way to do it. Sometimes I forget. I always remember this one. Let's let you know how this goes. I always remember this one, the sine squared of theta plus the cosine squared of theta equals 1. I remember that. And since I want the cotangent, let's say I divide by sine squared. And that's going to be 1. And that's going to be the cotangent, remember, cotangent squared of theta. And that equals, and what's 1 over the sine? Cosecant. All right? Well, you can read that. But so that's a way to remember that this is the same thing as the... Okay? So that equals that. And you can kind of derive it by dividing the one you know, the easy one, sine squared plus cosine squared equals 1. Just divide that by the sine squared. And 1 over sine squared is the cosecant squared, so that's how you can come up with that identity. So forget it. So, let's see, so now I've got the sine squared. Let me write it over here. So it's the sine square root of theta times, so this becomes cosecant square root of theta. Does that equal 1? Well, that's the sine square root of theta. And what's the cosecant? The same thing. Times what? 1 over sine square root of theta. And what do these sine squares do? They cancel. So we just have 1. So it's checked off. Okay, that's 15. Okay, let's try number 17. Pardon me. 17. Okay, here's number 17, and this is going to be sine. The sine of t times the tangent of t equals 1 minus the cosine squared of t all over the cosine of t. Boy, this looks really strange. Okay. Okay, well, sometimes we have to work on both sides to get this to be the same thing. This looks like this might be a candidate for that. Let's take a look at the left side first. I got the sine of t, and the tangent is the same thing as what? Sine of t over, well, the cosine of t. Is that all right? Well, I can get this now. Now this is looking better. Because what's the sine times the sine? That's the sine squared of t all over the cosine of t, right? Question mark, question mark, question mark. Don't know yet. And remember we talked about this. What's the sine squared? Isn't that the same thing as 1 minus the cosine squared? Remember the sine squared plus the cosine squared equals 1. Remember this. And you know, you might visualize this for a while until you know. The sine squared of t plus the cosine squared of t equals 1, right? So if I solve for the sine squared, what's the sine squared equal to? 1 minus the cosine squared. So there we go. So we'll write this as 1 minus the cosine squared of t over the cosine of t, and that does equal that. And there's your identity. Okay? So that wasn't so bad. Just remember, we have to remember this one. But this leads to this. Okay? All right, that was 17. Do we dare have a chance for one more? Let's try one more. 19. Here's 19. This is 5.1 homework. Number 19. Does this equal CS cosecant of t, secant of t? Okay. Now, the more these get different from the sine cosine, it's more challenging to get these to look the same without working on both sides. You can work on both sides. That's fine. So let's see here. There's lots of ways to do them. I've got two terms here, two factors. These are times each other. So I can set these up as factors. And listen, this is a cosecant, isn't it? I got two of these, so why don't I break this up like this? Isn't that the same thing as a cosecant squared? Yeah. So I got two of those. And I've already got that here, so see, I've already got part of my identity already done. So why don't I put the cotangent underneath here? I guess I could do that. Okay, now let's see, what can I do here? So I want to get this to look like, so I got this, the green part's okay, so I want to get this to look like this. How can I do that? Well, Let's go sine and cosine and see what we can get, because this is going to be what, 1 over the cosine, right? So let's see if we can get something like that. So again, we're just going to carry this for completeness. So this is the CSC. I don't want to mess with that. And this is the cosecant is the same thing as what? 1 over the sine, right? So I've got 1 over the sine on top. And on the bottom, I've got the cotangent, and the cotangent is the cosine over the sine, isn't it? There we go. So that's looking a little bit better. So now I got a complex fraction. Can I multiply the top and the bottom by the LCD, which is the sine of t? Yes, multiply the top and the bottom by the sine of t. So those cancel there, those cancel there. So I just end up with 1 over the cosine. So I got the cosecant of t times 1 over the cosine of t. Well, what's 1 over the cosine of t? Isn't that the secant? So now I've got the cosecant of t times the secant of t, and I'm done. That's what I wanted. Cosecant of t times the secant of t. Okay, those are t's, sorry. They start to look a little bit like f's. So that's checked. Okay? So we did get the left to look like the right. Okay, that's number 19. Hope that helps.